Welcome back to part 2 of this Django course where I'll be showing you how to set up your database tables in the form of models. Every full stack application needs a backend and every backend needs a properly designed database. From working as a data scientist to building countless number of full stack web apps, I can tell you for sure that this genuinely can be the make or break of a platform. Now, if you missed part 1 where we set up the Django project, go back and revisit that. Otherwise, let's get into it. In the first part, we set up the project and it was kept quite generic, to be honest. We added some configurations, we added a core sort of app within the Django project. But now we're going to step things up and we're going to focus our build on building an e-learning platform. One of the reasons why is because this will give us a really good opportunity to create a hierarchical structure within the database. And just very quickly, we're going to be doing a few things. I'm not going to dive into too much detail with this now because obviously we're going to be working through it. We're going to be using some mix-ins. We're going to be creating a lookup app. We're going to create the hierarchical structure between the course, the module, and the lessons. We're going to use some fields that you may not have heard of, so things like many-to-many fields. We'll add some custom methods to the models to allow for things like calculations, and then we'll extend the default Django user model as well. So let's get started. First thing we want to do is we want to create the additional models that we're going to use. So I'm going to create not the models, the apps. I'm going to create the users apps and these lookups apps. So you can see that these have been populated on the left-hand side now, so that's fine. Now that we have created these new apps, we need to add these apps to the installed apps definitions. So we're going to add users and we're going to add lookups. So now when we migrate the models, they'll be registered and migrations will run. So as I said, the first thing that we're going to do is we're going to focus on mix-ins. So let me copy this code block and then I'll explain what's going on here a little bit more. And we're going to copy this into a file within the core app and we're going to call it mixins.py. Now let's focus in on a few things. Now, as you can see, these mix-ins, they inherit the Django model class. So these are in fact a model themselves. However, within this class attribute, you can see that we're defining that they are abstracts, which means that they're not actually official models. They're just abstractions of models that we're going to use for inheritance, essentially. So the primary reason for these mix-ins is that we are going to mix these in to the model definitions of the database tables that we design. And what this will mean is that for the tables that we design, when we add these mix-ins into the definition, it will inherit all of the properties and all of the fields from the mix-ins. Therefore, we don't have to keep reproducing and writing out the same field names for all of the models. If we want standard field names, things like when was it created, when was it updated, what order should these objects be ordered in, what's the name of this object, then we can just reuse these mix-ins, which is really nice. And mix-ins can even be used not just for models, they can even be used for API views as well and other classes. So these are really useful in Django. Now the last one here, this slug mix-in, this is an interesting one. And this is particularly useful when it comes to building web applications. So a slug is not just a slimy looking snail without shell, but it is also a unique string which identifies some content. And they're really common and useful when it comes to search engine optimizations, SEO. So as an example, you could have a website and that website could direct people towards an online course. So it could be something like www.website.com/courses and then a whole bunch of like unique numbers, right? And then this unique number could be the ID of the course. This is fine and this will work as you'd expect. But when it comes to search engine optimization, search engines can't really associate this with anything. So all of a sudden, this web page doesn't become very indexable or searchable from a search engine perspective. However, if you replace this ID with the name of the course, so for example, Python Django full course designing models, all of a sudden this becomes much more human readable. So not only for end users is it a lot more digestible, but for search engines, it also becomes much better to index as well. This is really good. So this is an example of a slug, and a slug will be unique to a particular model. And then let's just say we had two parts to this particular course. This slug mixin here, as you can see, there's some logic here, which essentially is iterating the name in case there's a duplicate. So if we have two courses called Python Django full course, first one will be named 1, and second one will be named 2, as an example. So that way it's always unique. So these mix-ins can be really useful. And as I said, the primary purpose of these is to stop us from having to keeping on adding the same attributes to our database tables every single time. We can basically just reuse them from these mix-ins. That's great. So now let's move on. Now let's actually start creating some of our models. So now what we're going to do is we're going to create some models in the Lookups application. So the reason why we created this Lookups application, and I found this from building Django applications for years. Quite often I'll build a database table, such as the name of a course, and then I might want to add some tags to that course. So for example, the different types of technology that are being used, the level of difficulty of the course, that sort of thing. But then those tags could be reused across different parts of my application as well. They could be associated with particular types of profiles. They could be associated with different types of teachers, for example. So for these sorts of models, and for this sort of data, where would be the best place to store such reusable and flexible data? And so having a separate application, such as this Lookups application, to store this generic information that can be applied across your Django project is a good way to do it. And as you can see from this code block here, we're inheriting our mix-ins. And actually, for these particular database tables, because all we really need to include are the fields from the mix-ins, we don't actually need to declare any properties or any fields for these database tables. So for these two tables, the tag table and the topic table, that is literally it, essentially just 4 lines of code. So now we've actually just designed 2 database tables. Now remember, of course, when we create these tables, they are actually going to have a certain number of fields because they're going to be inheriting from all of these different mix-ins. So as an example, this tag field and the topic field, in fact, they're going to have all the fields from all of the mix-ins that we created. So each of these tables is going to have created at, updated at, order, name, slug, and a slug field. But because they're inheriting it from these mix-ins, we don't need to declare them here. So it helps to keep your code really nice and concise. So now let's move on to the user profile table. So I'm going to copy this block of code once again. Let's come into the users app this time. Let's paste this in here. Now, this is the first time that we're going to be creating a class-based schema, as we would have seen in the previous app, but we're actually going to be defining specific fields here. And this gives me a chance to talk about how Django works exactly. So in a database, you have a number of tables. You can design those tables however you wish. And then what makes a relational database in particular very powerful is the ability for you to be able to connect those tables together and join those tables with different relationships. And traditionally, in a traditional relational database, these work and these function using structured query language. In other words, SQL. So back in the day, knowing and writing SQL was really important. And even today, as a full stack developer, it is also important for you to understand. However, in a tool like Django, you are able to essentially write raw SQL to then send to the database to retrieve information or to create data. However, it's encouraged to not do that unless completely necessary. And there's many reasons for this. One of the reasons is because of SQL injection attacks, which is a form of cybersecurity attack. Let's just say you have like an online form where people are signing up. What used to happen was people would enter information into these forms, with their name, their emails, their address, all that sort of stuff. But then if somebody malicious knew or was able to find out that at the back end of the application was in fact injecting raw SQL to the database, then rather than putting genuine information into these forms, like their name, their email address, their personal address, they would actually write raw SQL in these input forms. And then that raw SQL would then get injected into the larger block of SQL, which is getting injected into the database, which could then cause all kinds of terrible things to happen, like deleting all of the data in the database or returning loads of personal information to the client. So that's not good. So one way to get around that is to use something called an object relational mapper, an ORM, and Django has that built in. And the way that we write our models files is leveraging that ORM. So we're not defining raw SQL in these models files. What we're doing is we're defining the schema, that is the structure of the tables, in this format. So we define a class, and this particular class is the user profile class. So this is going to be a table in our database. And then all of the fields that come underneath it, these are going to be the columns in the database. And then if we need to add columns or update columns, we simply come into this models file, and we might want to update something, such as the maximum length that the display name can be. And that's how we manage our database. And then when it comes to retrieving data from the database, creating data, updating it, or even deleting data, once again, we do not interact with the raw SQL. We use these classes that we define to interact with the data in the database. So everything is abstracted away from us, and it makes it much safer. Now, coming back to this particular class, so this particular database table. So this is the user profile table. The reason why we're creating this is because Django has a built-in user model, which is really useful. However, it's very basic. It only really includes simple information such as first name, last name, email, and password. But in most web applications that I've worked on, the platform wants to store more information about their users, such as a display name, maybe a profile picture, maybe a short bio that can be included on their profile, all that sort of stuff, right? Could even be payment information, their subscription tier, the list goes on. So in order to do that, what we can do is we can extend the base user table, the default user table, with an additional table. And you can call this whatever you want, but profile or user profile seems to usually work quite well. And then all we have to do is we have to link this table to the default Django table. So we define the user that this profile is related to, and we use a one-to-one field, which means that for every one user, there must be one profile. Now, just to explain some of these parameters, so this first field in this one-to-one field that we define is essentially telling Django, well, what is the user table that we're mapping to? And there's a few ways that you can map it to this. So you can import the settings from django.conf, and you can put this particular value in here. Or you can import the actual user model using django.contrib.auth.models, and you can put this in here like this. I'm going to go with the second option. Now with related fields like this, you can choose what happens when they are deleted. And in this particular instance, we're telling the database to cascade these deletions, which means that if one of the user models gets deleted, then the associated user profile will also be deleted. And then after this, we've just got two very basic sort of fields in the table as well. We've got a display name and a bio, and these are using quite common fields that you might have come across if you've done some basic Django stuff. So we've got a char field and we've got a text field. That'll do for now for the users model. Hopefully that gives you a bit of insight into the ORM. So now let's move on to the core e-learning models. So once again, I'm going to copy this and then we'll walk through it. So last time from the previous tutorial, we created a very basic model. It was literally just this note. We're not necessarily going to be needing this anymore because now we're focusing more on an e-learning platform. So let's just overwrite this and paste this in. Right, let's walk through this. So let me just collapse this code so that we can see all the different models that we've got. So once again, as I explained at the start, we want to build almost like a hierarchy of how these courses are arranged. So if you think about how a course works, you would sign up to a course, and then within the course, you might have a series of modules. And within each module, you then have a series of lessons. So these first three models reflect that structure. So let's have a look at these. Let's start with the lesson. So you can see, once again, from the definition of these three models, that we're inheriting a lot of properties from the mixins that we created, which is great, which means that our definitions are going to be really concise and simple and clean. So then all we need to do is define the additional fields, which aren't inherited from these mixins. So the first one is the module. So obviously each lesson needs to be associated with a module. So we're going to use a foreign key for this, and this is going to relate to the module class. We can then define the content for that particular lesson. So we're just using a text field for this. Obviously, as you build out a more complicated e-learning platform, you can update this. You might want to include some JSON information, some links to videos, all that sort of stuff. And then we're storing a field called the duration in seconds, which is essentially just an integer value. It tells the student how long this lesson will take them to complete in the number of seconds. And then lastly, within this meta definition, there's a few things that we can define here. But for now, the only thing I'm going to define is unique together. And what this does is it defines the rules for uniqueness of these lessons. So essentially what we're saying here is that any combination of module and slug has to be unique. So we can't have a lesson that's associated with the same module and has the same slug. The combination of these two fields must be unique. So this unique together definition can be really useful across all of your different models if you want to enforce uniqueness. And if someone was to try and create a lesson that does have a non-unique combination of module and slug, then the database will come back with an error. Okay, so now that we've covered the lesson, let's now roll up to the modules. Once again, inheriting lots of properties from all the mixins, which is brilliant. So really all we need to define here is which course this module is associated with, because we've already got the name from the named mixin, and a description for the module. And then once again, we're going to define how we want this module to be unique as well, this time just based off of the course and the slug. And then finally, now let's roll up to the course. We're going to include a description. We're going to include a Boolean flag to see whether it's been published or not. Something like this is quite useful for filtering the data really easily. So as an example, an administrator might want to deactivate a course or maybe release a course, but it's not quite ready for publishing yet. So they can simply just go in and they can just change this Boolean flag. We're going to leverage the lookups tables that we created. And the way that we're going to define these are through many-to-many fields. So in database design, there's many different ways that you can link fields. You can have a foreign key, you can have a one-to-one, which is what we saw in the user profile table. You can have a many-to-many, and there's many other ways that you can do this too. But what this many-to-many definition essentially means is that in database terms, we can associate many different courses with many different topics. So it doesn't matter if we have 3 courses and all of those 3 courses all have the same or a completely different selection of tags or topics associated with it. So in layman's terms, essentially what this will allow us to do is this will allow us to add as many different tags and as many different topics to this course object, which is great. And same for instructors as well. So we're going to actually have an instructors field where we can define which users, i.e. which teachers are associated with this course. And then finally, students as well. Now, one more thing I'll show you are these 2 method definitions at the bottom of the course class. Quite often when you're working with the Django ORM, you'll be doing all sorts of aggregations and potentially calculations to then return relevant information to your client. And you can write out these aggregations and calculations yourself, or you can essentially delegate this processing straight to the database in the form of these sorts of methods that you can create. So as an example, this method called total lessons, what this will do is it will give you this method for any of the course objects that we'll use later down the line, and it will calculate the total number of lessons for that particular course. So it's essentially a helper method that you can use to run calculations. And then similarly, we've got a completion for, and this one actually takes in another parameter called user. So for a given user, this will calculate the completion for this user for this particular course. So just to kind of give you an example. So let's just say, and we'll be covering this later in the course, but let's just say we have a course which we currently have in our Python code. And this course is defined by the variable name called course, right? Now, assuming that this course is indeed a single instance of this class, what these methods essentially mean for you now is that you can use these methods. So you can write course.total lessons, and then this will give you a number 2 off the back of it. So rather than you having to write out all of the code to actually calculate this yourself, you can literally just use this method. And similarly, if you did completion for and you added in your user, it would give you, let's just say 0.25 as an example. So these methods can be really helpful. Okay, so we've gone through the kind of hierarchical structure of those 3 models. The last thing I want to do is go through these additional models, so the enrollment and the lesson progress. So we've got our kind of hierarchy here, which is great. But then how do we manage who is enrolled in what course and the progress of the students on those courses? So that's where these 2 models come in. So for the enrollment, we simply just define which course we want a student to enroll in. We then define which user is associated with this enrollment, and then we can have an additional timestamp field as well, which is when they're actually enrolled at. Now notice we have another method here, and because we have defined course, which is linked to the course class, it's essentially inheriting the property, i.e. completion for, from this model, and we can use the user from the enrollment definition to then very quickly give us a progress percentage calculation for any particular enrollment. So that's a really nice bit of inheritance there. And one other thing to notice as well. So if I come up to here, Yes. So in the course model, notice we have a student's definition, as you'd expect. So this field in particular gives us a way to track what students are enrolled on a particular course. And we're using a many-to-many field. However, in the definition of this many-to-many field, we define a parameter called through. And what this means is this is telling Django that we want to add users to this students field, which is fine, but we want to go through the enrollment class. And this enrollment class is related to this down here. So actually what we're adding to this many-to-many field is not necessarily an underlying user model. We're actually adding enrollments, which include the course that is associated with the user and a whole bunch of other information as well. And lastly, the lesson progress model. Nothing too fancy going on here. This is all kind of stuff that we would have seen in other models. So we've got our user model to keep track of, the user and their progress, the lesson, a Boolean flag to let us know whether or not it has been completed, and then a timestamp to let us know when it was completed. So essentially, this is just a Boolean flag to let us know whether or not a student has completed a lesson. So we covered quite a lot in this particular models file, but this is all really powerful stuff. Okay, let's test this out now. And let's start interacting with some data in this database. So first thing that we want to do, because we've been making a whole bunch of changes to the models files, because the applications that we created are all registered in the installed apps array, we need to add these migrations to the database migrations list. So almost there. There we go. Okay, it's coming back with an error because we no longer have the notes model. And in the admin file, it's referring to the note. So I'm just going to remove this because we're not going to need that note anymore. Okay, great. So the migrations have been created. That's brilliant. And now we can make these, we can migrate these essentially. So Python manage migrate. So now these changes have been reflected in our database. So for this part, we're going to interact through the object relational mapper, through the ORM, and we're going to interact with our database straight from the terminal. And the way that we do that is let's just use a management command called shell. And this is going to open up an interactive terminal where we can start interacting with our Django application essentially. So in this code block here, I've put some snippets that we can start using. Obviously, you don't need to stick to this exactly, but we're going to use this as a bit of a template. So first of all, I just want to make some imports before I actually start creating any data. So let's just do this, django.utils time zone. This will be useful for some of the timestamp based fields. Okay, that's everything that we need for now in terms of our imports. Now let's create some users. So let's create an instructor. Obviously, you would never use a password like this in production. For testing purposes, it's fine. And let's create a student. Okay. So now we actually have some data in our database. We just created two objects, two users. Now, here's a top tip. We haven't created or connected a remote database to this repository. So by default, Django uses a SQLite database, which, as you can see in the left-hand side, File Explorer is right here. Now, if you're using Visual Studio Code or another similar IDE, you can probably download an extension which allows you to explore a SQLite database. So if you're in VS Code, you can come up here and you can type this, and you can actually open a SQLite database. And it'll ask you which SQLite database you want to open up. And then you'll notice there's a new sort of like tab down here. So now if I expand this and open up the SQLite database, I can actually now see all of the tables that have been created in our database. Notice the naming convention. So as an example, if we look at the core app here and the models in here. So within the core app, we have the course table, and notice the naming convention. So you've got the name of the app, core, and then you've got an underscore, and then you've got the name of the table. And then you've got all of the other tables as well. So you've got core course instructors, core course tags, etc., etc., core enrollment. Now, the reason why we have core course instructors and core course tags for these many-to-many fields is because that's how the many-to-many fields are created within the database. They essentially create a mapping in a separate table. Now, none of these tables will have any data apart from the user table. So this will actually be in the auth_user table here. I can expand this out to see all the different variables that are associated with this particular model, or if I click on this play button up here, it'll actually show me the data. So this is pretty cool. Okay, now let's create some more data. Let's create a profile for a particular user. So we're going to create a profile for the student. Yeah, that's right. So user profile.objects.create. And then we need to define the user. So we're going to use the student here. And we're going to change the display name to student month. Okay, and you can see that it's returned an object here, essentially, which is exactly what we want. So what I do now is if I come into the users_user profile table, you can see here that a student has been created and it's associated with the user by the ID number 3. That's great. Now let's create some lookups. So we want tag is equal to tag.objects.create. So we're creating a Django tag and we're going to create a topic. Cool, so we've got a tag of the topic now. Now let's create our course. And before I go any further, essentially us writing commands like this, so us using the name of the model, such as tag, and then making use of the different methods that are available. This is us leveraging the ORM. So by us utilizing the classes that we've defined and not writing SQL ourselves, we are using the power of Django as an object relational mapper to use the schemas that we've defined to then generate all of the legwork and all of the SQL in the background and to then create these tables for us without us having to worry about all the technical details of writing SQL and interacting with databases. So as we're creating these tables, we are leveraging the ORM right now, which is really valuable. So let's go back to creating the course. Okay, so we've created our course. Now for a many-to-many field, you don't define a many-to-many field in the create method like this. You can't just pass in the name of the field and then the value of the field. When you're assigning data to a many-to-many field, what you do instead is once you've got the actual object stored in a variable, such as course here, so if I just return the value of the course, you can see that this is related with an actual, an instance of a course. So this variable stores the course that we've just created. What you do is you use the name of the object, you then write the name of the many-to-many field that you want to add it to, and then you use one of the helper methods that comes with a many-to-many field. So you can add data, you can set data if you want to pass in a list, you can, I think it's removed, and you can clear. For now, we just want to add, and we're just going to add a single tag. So this will add the tag that we've created to the tags for that course. And then if we had another tag in the future, we could just then do that again. So we can add tag course.topics.add topic, course.instructors.add instructor. Cool. Okay, now let's have a look to see if this has changed the tables at all. So if I come into the course, here we have our course information. So you've got, all of the mix-in data that we added. So we've got the timestamps, we've got the order, we've got name, we've got slug. See how this has been generated, the slug value, which is really nice. Now this base table, which table was this? This was the core_course table. This doesn't actually store any of the many-to-many relationships itself. As I explained earlier, when you define a many-to-many relationship, it actually stores it in a separate table, which then relates back to the table that it's related to. So in the example of tags, you can see here, it's literally just a table of essentially lookup information. So you've got the course ID and you've got tag ID, and it's just basically a table that stores the relationship of many-to-manys. And similar for topics, it's going to look very similar to instructors because we added one tag, one topic, and one instructor. So that is as expected. Then if I come into the lookup tables, let's just have a look at these as well. As you'd expect, in the tag table, we've got our Django tag, and in our topics table, we've got our web development tag. So everything is working very nicely. Okay, now that we've got our course, let's create a module. So module. Okay, and let's create a lesson module. Perfect. Now let's just carry on going. Let's add some more data. So now let's do, let's create an enrollment for the student. So we're going to say that the student user is enrolled in the Django Basics course. Perfect. And let's just mark this lesson as complete. I'll tell you what, I'm going to add this to a variable as well, so we can reuse this afterwards. So lesson progress objects.create. We want user is student. Lesson completed. It's true. And completed at. This is where we're going to use the time zone Django util that we imported earlier. Now, so it's just been completed. And then if I just print lesson, you can see that it's associated with the lesson progress object, which is what we want. So now just to test some of the methods that we created. Now that we have a student, we have our course hierarchy, we have a student that is enrolled in that course, and we have some progress that's associated with that student's enrollment. In other words, this student has completed the lesson within the course. If we now use the course object and we leverage the completion for method. Now, if you remember from the definition, this also takes in a user parameter as well. So we need to pass in the student. It comes back with 100%, meaning that that student has completed 100% of the lessons in that course. Now, if I go back to the lesson model, and I say, you know what, lesson dot completed, this is false. And if I persist these changes, now if I run course dot completion for student again, it comes back with 0. And that's because now the information about the progress of that student on that lesson is now tells us that that student has not completed that lesson. And that's why it comes back with 0. So that covers it for the models part of this course. We may revisit this later to add some more advanced stuff as well. Actually, even in this lesson, we've gone through some quite advanced stuff. Stay tuned because the next part of this course is going to be focused on serializers, which is going to be very closely tied to what we've done with our models. So I hope you enjoyed this lesson. Don't forget to like, subscribe, and hit that notification bell as well so that you're notified of when the next part of this course comes out. And since you're here, why not check out some of my other videos to do with Django and full stack development, which include some of the top tips that I've accumulated over the years. But for now, I'll see you soon.